welcome back. Today we're going to talk about multiplying fractions. One of the things that can help us when we're multiplying fractions is to look at it from a visual standpoint. And so what I want to do is I want to look at 3/4 times 1/3 in terms of what it means. Really, if we wrote this as words, it would be 3/4 of 1/3. And so when we look at this, let's model this using this rectangle and dividing it into pieces. So 3/4 of 1/3. Well, the 1/3 is what I want to try to model right here, because the 1/3 is what I'm taking the 3/4 of, and so I'm going to divide this. And if I've got 1/3, it's really this piece here. Okay? Now, I want 3/4 of that. And so what I need to do is I am going to divide it the other way into fourths. Okay? Now, this is the 1/3. Okay? That's the 1/3 of the whole rectangle. And I want to take 3/4 of that. So when I divide it into 4 pieces, really what I'm asking is, what are these 3 pieces? How would we represent those? And if I look at it in terms of the whole, 3/4 of 1/3 is 3/12, because there's 12 pieces here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 3 of them out of those 12. Okay, watch again. This means 1/2 of 3/5. I've got 3/5, so I need to divide this into 5s. Okay, and 3/5 is what I've got. So 1/5, 2/5, 3/5, and I want half of those. And the problem is I can't take half of them because there's 3 of them. So I need 1.5 of those bars. So what I'm going to do is, this is my 3/5, right? And if I take this and I divide it the other way, that's 1/2. So what's 1/2 of the 3/5? It's these. So I divide it one way, shade, divide the other way. So 1/2 of 3/5 is equal to 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Let's predict using those models. 1/2 of 3/4. So notice what happened here. What happened was, when I multiplied 3/4 times 1/3, I got 3 on top and 12 on bottom. When I multiplied 1/2 by 3/5, I got 3 on top and 10 on bottom. So what I'm going to predict is, I am going to predict that 1/2 of 3/4 is going to give me 3/8. I'm going to put a little question mark here because that's what I'm trying to assess, whether that's actually 3/8. And so what we need to do is, let's model it. 1, 2, 3, 4. So I have 3/4. So this one, and this one. What's modeled here is 3/4. And I want half of that, so I'm going to divide it the other way. And this is 1/2. Well, what is 1/2 of 3/4? 1/2 of the 3/4 would be, take the 3/4, these 3 big bars, and divide them in half. It's these here. So 1/2 times 3/4 equals 3 out of 8. So it's these 3 out of the 8 pieces that are there. Try the last one on your own. Multiplying fractions then is just a game of saying, how do I shortcut the drawing of the fraction boxes? Well, multiplying fractions looks like this. 1/2 times 4/5 is going to give me 4 over 10. Okay, which is 2/5. Or 2/3 times 5/7 is going to give me 10 over 21. Okay, so I multiply and I generalize it to say this. A over B times C over D is A times C over B times D. Okay, so that's the basic gist of it all. What does this look like when we put it into practice down here? So let's do the shortcut method. 1/3 times 5/6, could do it with the boxes, that would work just as well. But I'm going to shortcut it, and on top I'm going to have 5, and on the bottom I'm going to have 18. Because it's 1 times 5 over 3 times 6. Gives me 5 over 18. In the same way over here, I get 5 times 2 over 7 times 3, which gives me 10 over 21. Let's look at the general model for mixed numbers. Now, I've got these mixed numbers, and there are ways to do it. You could convert to decimals or a bunch of different other things. What I'm suggesting to you is simply take it and convert it to an improper fraction. So no matter what method you like, we're going to end up doing 4 times 5 plus 1 over 4, so 21 over 4, times, and we'll do the same thing up here. We'll have 3 times 4 plus 2 over 3. So it's 12, 13, 14 over 3. Now, another piece that we can take into account here is the fact that these are pretty big numbers, right? They're pretty big numbers. And so what we can do is we can cross-reduce. And cross-reducing is looking at factors that are across from one another, i.e. right here. Okay? And ask ourselves, does something go into both? And I say go into, meaning do they share factors? So do 4 and 14 have a common factor? Well, they're both even, so something we can do is we can do this. We can cross these out because 2 goes into 14 7 times, and 2 goes into 4 twice. In the same way, 21 and 3 also share factors, and they share a 3. So 3 goes into 3 once, 3 goes into 21 7 times. And what I'm going to do is now I'm going to simplify this by doing 7 times 7 over 2 times 1, 49 over 2. Okay? So that's the short way to do this, by cross-reducing. Okay? I want you to try the next two. Thanks for watching, guys. We'll see you next time.